Let us practice the rule how to compute the area bounded by the graphs of two functions. Consider the functions sine and cosine, and we want to find the area of the region between two intersections of these two curves. If we sketch the picture, then sine of x looks like that, between 0 and 2 pi, and cosine looks like that. And we see these two curves intersect infinitely many times in infinitely many distinct intersections. And here we have just two of them. So let us consider the region between these two intersections. That means we want the area of this region. This one will be symmetrical and all the others will have the same area. So first we want to find the intersections A and B. So we consider the equation sine of x equal to cosine of x. In this simple case we can guess from the properties of sine and cosine. But let us play a little with this equation. If we divide by cosine, we can say that this fraction is tangent, and tangent is equal to 1 at arc tangent 1, which is pi quarter. Because this is pi half, this is minus pi half, and this is half of pi half, which is pi quarter. Tangent is periodic with period pi, so another intersection will be with pi and possibly plus or minus any integer multiple of pi. Well, and these two values, 45 degrees is A, and 1 pi more is pi plus pi quarter, which is 5 quarters of pi. Well, so the area is integral from A, that means pi quarter, to 5 quarters of pi. And now we must carefully choose the order of the two functions. The upper function is sine, and the lower function in this interval is cosine. Well, and we can easily find the antiderivatives, which are minus cosine minus sine from pi quarter to 5 quarters of pi. If we take the functions sine and cosine, then they have a nice property, namely if you shift the argument by pi, you get the opposite result. So minus cosine at pi quarters of pi is equal to pi cosine at pi quarter, which is the square root of 2. Minus sine here is plus sine square root of 4, which is again minus sine here is plus sine at pi quarter, which is square root of 2 half, minus, and if we take the same value just shifted by pi, then this expression in the bracket will have the opposite sign, but we subtract because this is the lower limit, so we add the same expression once again. which in result is 2 square root of 2. Okay, if you don't like the simplifications, you can substitute x, this value for x here and here, minus this here and here, and subtract, and you get the same result. So the area of this, well, what does this region resemble? I imagine a bird or a dolphin jumping out of the sea, and the area is 2 square root of 2.